So an arithmetic series has a first term a and a common difference of 2a plus 1. Prove that the sum of the first n terms of this series can be given by that. There are a couple of ways of doing this. What you could do is you could prove the general summation formula and then say that d is equal to 2a plus 1 and do it that way. Or you can just do it with using the 2a plus 1 as the common difference. So the way it works, the way Gauss did it, was he said, okay, the first term is a, and we're going to add the second term, so that's a plus 2a plus 1, plus the third term, which is a plus 2 lots of 2a plus 1. And he did that all the way up to the last term. Now the last term is going to be, we know that that's a plus n minus 1 d. So in this case, it's going to be a plus n minus 1 times by 2a plus 1. And the second last term is going to be a plus n minus 2 times 2a plus 1. And I'm just going to do that last term because I did the first three, so I'm going to do the last three as well. So a plus n minus 3 times 2a plus 1. So that's the whole sequence up to the nth term, and then what he did is he wrote it backwards. So Sn is equal to last term, which was a plus n minus 1 times by d, which was 2a plus 1, plus a plus second last term, so n minus 2 times by 2a plus 1, plus third last term, etc. Plus dot, dot, dot. Right, and then we got the last three terms. So we've got a plus 2 lots of d plus a plus d plus a. And then we've got them in pairs, so we can add these two terms together, add these two terms together, add these two terms together, etc. And so what we know is when we add them together, they all give you the same value. And so we can just add the first two. So we get 2a plus n minus 1 times by 2a plus 1. And we know that that's going to happen with all the pairs. Alright, now twice, and that's enough. And then again and again. So how many times have we got that? Well, we've got that n times. So we've got n lots of 2a plus n minus 1, 2a plus 1. And then we want to find Sn, but we've got 2Sn because we added the two lines together. So divide by 2, and we end up with the proof and the formula that we needed. You get that? Okay. Now in part B, they tell us that given that a is 4, find the value of n such that Sn is 11225. So a is 4 and the summation is 11,225 is equal to n over 2. A was 4, so we can say that's 8 plus n minus 1, 2 lots of 4, 8 plus 1, so that's 9. The key thing with this one is you could have done part B without even doing part A, because part A was a proof, it was a show that, so that's nice. We can still do part B even if we're not sure about part A. So don't just skip the whole question just because you can't do part A. Do have a look, and sometimes it's possible to do it, especially after a proof. So let's just simplify this bracket. So it's going to be 8 plus 9 n minus 9. And I'm going to times by 2 at the whilst I'm doing this. So that's going to give me 22450 is equal to n, and then I've got 9n minus 1 in here. And let's expand. And so we end up with the quadratic if we take everything to one side. And it factorizes, but naturally you don't need to factorize it. We can just whack it into our calculators. But it does factorize to give us that. And so n is equal to minus 449 over 9, or n is equal to 50, but n can't be negative, it's a number of terms, so n has to be greater than 0, so therefore n is equal to 50.